All right, you can use a similar method to solve absolute value inequalities that involve a greater than symbol like this. As always, the first step is to isolate the absolute value expression, then work with the compound inequality. So here, this is our absolute value expression right here. And we need to get this by itself, just like we did in the last example problems that we went through. Right here, there's this -4 on this side of the inequality, so we have to get rid of that and isolate this absolute value expression. So let's go ahead and try to do that first. So our first step is just going to be adding 4 to both sides. That cancels, and then we did it. We now have this absolute value expression on this side of the inequality by itself. -1 plus 4 is 3. Okay, now we're ready to break this into a compound inequality. So when there are these absolute value symbols, I have seen some students try to add 5 to both sides to get x by itself, and you cannot do that. When these symbols are here, it's almost like everything in here is in jail. You can't, nothing can get out of these absolute values symbols. You have to break this into 2 equations. Once you do that, then you can start isolating x. But you can never move anything when you see these absolute value, anything inside, when you see these absolute value symbols there. It's in jail. Nothing can go in and nothing can go out. Everything is just kind of locked in place. Okay, but let's go ahead and unlock it. And how we unlock it is by making it a compound inequality, which means basically we just put it into 2 inequalities. Just like we did with absolute value equations when we split it into 2 equations. Oh shoot, this is going to be an x. Make that an x. X minus 5. So this, you write exactly the same, is greater than 3, okay? The only difference between absolute value inequalities and absolute value equations is that when we write this next one, and we multiply this by -1 and making that a -3, we have to go ahead and flip that sign, okay? So that's the only thing that's kind of different. Now we have our compound inequality. This is either an and or an or problem, so we have to determine which one it is. So it's kind of like interpreting the results. But before we can do that, we have to solve each one of these. So let's go ahead and solve. 3 plus 5 is 8. And then we solve this one. And we get x is less than 2. Perfect. Now I just want to go ahead and graph these because this is not my answer, okay? This is not the answer. You have to interpret this and then write the answer. So to interpret it, I like to just kind of graph it, and then I'm able to kind of see if it looks like an and or it looks like the or shape, and then I know how to write my answer. So I'm going to go here first. It's 8. It's going to be an open circle. Okay, x is greater than 8. And then we go to 2. It's an open circle as well. And x is less than 2. So if you see here, we definitely have that or shape. All right, awesome. So this is an or, so we need to write our answer as an or. So remember, you always write the smaller one first on the left. X is less than 2, and then you have to write the words or. Okay, x is greater than 8. Then you write the bigger one there, and there's your answer, and here is the graph. All right, perfect. Okay, let's go ahead and work out a couple more examples. So let's look at 5 here. So we're just going to solve this and then graph the solutions. So again, we want to isolate this absolute value expression. So I'm going to subtract 4 to both sides. Perfect. Now we are ready to break this up, get rid of this. We've isolated the absolute value expression. So once we break it into 2 inequalities, we no longer need those symbols. So we have just the first one as it is. And then the second one's going to be multiplied by a -1, and we have to remember to flip that sign. All right? Once we have our results here, we're just going to go ahead and graph it to see if it's an and or an or, because we need to interpret this information. We are not done yet. So we go to 1. It's going to be a close circle, and x is greater than 1. So it's everything this way. And then we go to -1, and it is also a closed circle. And this says x is less than or equal to -1. So it's everything this way. And what shape is that? Yes, that is the OR shape. So now we have to write our answer. We write the smaller one first, which is this one. You always write the x on the left. X is less than or equal to -1, or x is greater than or equal to 1. And there we have our answers right there. All right, let's go ahead and look at the next example here. Okay, perfect. So we want to isolate this absolute value expression here. Okay, right now it's being multiplied by a 2. These are not parentheses. I've seen some students try to distribute this. It's like these absolute value symbols make this, it's like it's in jail. You cannot move this +2 out and go -2 to both sides. You cannot do that, and you can't distribute the 2 to both things inside. Nothing can go in and nothing can go out. This is like, it's jail for this x + 2 in here, okay? It just stays put. So we just need to isolate it and get rid of the 2. We know this is 2 multiplied by this, so we're going to do the inverse operation, which would be division, and we're going to divide by both sides. 2 divided by 2 is 1. And 6 divided by 2 is 3. Now we have isolated, now so we can like break x + 2 out of jail by splitting it into 2 inequalities. X + 2 stays exactly the same. And then on this second one, we need to remember to multiply 3 by a -1, which would make it -3. And in order to do that, we have to flip that sign. Okay? Now we just solve, now it's okay to solve both of these inequalities. 3 take away 2 is 1. We do the inverse operation over here. -3 minus 2 is -5. Now we just need to interpret these results, and I like to do it by graphing. So I'm going to graph the first. It's going to be an open circle at 1, and x is greater than 1, so it's everything this way. And then we go to -5, and it's also going to be an open circle, and x is less than -5. And so what does this look like? Yes, it looks like an OR. So we need to write the first, x is less than -5, or x is greater than 1. So there is our answer. There is our graph. We've interpreted it. We've done everything we needed to do. Okay? So now it is your turn, ladies and gentlemen, and I want you to try problem 7 and also problem 8. Okay? You're going to solve the inequality, split it into a compound inequality, interpret the results, and graph, okay? So for everything, if you need an example, look back on the previous examples that I've done, okay? But let's go ahead and get started. And here's my friend, the pauser. I can remind you to pause your device, workout 7 to 8. When you get done, press play, and we'll go over the results together. All right, see you in a bit. Okay, let's see how you did. We're going to isolate this absolute value. So I'm going to add, once my pen is working, 7 to both sides. -3 plus 7 is 4. Okay, now we have it isolated, so we're going to break it into 2 inequalities. The first stays the same. The second, we multiply by that -1 to get a -4. And when we do that, we have to flip that sign. And now we need to interpret, and I like to graph it. So let's go ahead and graph it. We have at 4, it's an open circle, and x is bigger. So it goes that way. And at -4, it's also an open circle, and x is smaller. So it's clear we have an OR, so we're going to write the first one, the smaller one first. X is less than -4, or x is greater than 4. So if you have this answer, awesome, and this graph, that is wonderful. If not, go ahead and make sure that your notes look exactly like mine, all right? Okay, let's look at the next one, 8. So we want to isolate this absolute value expression. We have to subtract 5 to both sides to do that. Okay, now it's time to split it into two inequalities. The first one just stays the same. The second one, this one always stays, but we multiply this 3 by a -1, and we have to flip that sign. Then we just solve both. Okay, now we just need to interpret the results. Okay, so I'm going to go to 7. It's a closed circle. X is greater than 7, and go to 1. It's also a closed circle, and X is less than. And this looks like an or shape. So we're going to write this smaller. X is less than or equal to 1, or X is greater than or equal to 7. If you got all of that right, awesome job. If not, go ahead and fix your notes and make sure they look exactly like mine. All right, see you in a little bit for the next example.